Actually, we talk about integrators. Okay, we talk about the different. We talk about two things. Okay, two important things is that first thing is that if it's in first order, okay, you are going in this direction, 90 degrees because it's a pole. Okay, and then if it's second order, if it's still a pole, okay, I mean this is a pole definitely. And then if it's second order, you have another minus 90 degrees. I mean sorry, in this case is for this case. You have another minus. Hold on. Okay. You have another minus 90 degrees. And then for that case, 3 cube, you have another minus 90 degrees. Right? So the higher order you are, the more 90 degrees you have in the negative for the pole. So let me repeat again. For a pole, the higher order you are, the more minus 90 degrees you have. So the more pole, so in the pole section, in pole, the higher order you are, the more minus 90 degrees you have. That's the key concept. And then I also talk about the magnitude. As the magnitude as the order increases, the magnitude is actually becomes so-called smaller. Okay, the magnitude becomes smaller. It shrinks faster. If I say you have a frequency of omega equals to 2, right? If I sum into this, I have 0.5 k of a magnitude. If I put it into a second order, I have half of this, which is somewhat a smaller magnitude. Then furthermore, if I cube it, I have a much lesser magnitude and so on, so much lesser. So as you can see, this is the trend. So this magnitude wise, how it works is that hold on, I may be wrong, but if the lower the magnitude, it means that you're moving faster to the origin. Okay, as you can see with an omega frequency of 2, okay, let's say if it's first order, let's say this is 1, right? So let's say everything is minus 1. If I have omega equals to 2, okay, I have minus 0.5 over here. And then in this case, for the second order, I have minus 0.25. And then for this case, I have minus 0.125. And for this case, I have much smaller, minus 1 over 16. Right? So it's much nearer, I mean sorry, it's over here lah. Because it's coming, sorry, what am I doing man? So hold on. So as you can see, as my frequency equals to 2, I am halfway over here. While if it's second order, I am much closer to the origin. And then if I am more higher order, I am more closer to it. And if I'm more higher, okay, I am much closer to the origin. I coming back to the change the arrow over here. Sorry, I'm coming back to the origin. That means I'm traveling in a more faster speed in the same sense. But definition wise, I can't guarantee you because I can't derive the thing yet. So, but for the integrators part, I hopefully you are clear. So let's come to this point. This is actually called the delay. Okay, if you were to check it out, it's a lag lah. It's a simple lag. Simple lag is 1 degree. Similarly, a double lag is second degree. Okay, and then this one is a triple lag, and this is a quadruple lag. Okay, so how does this lag actually works? In this case, I would believe that the lag will cause the system to have a more phase angle. Okay, you'll move slower. Okay, but as you can see, we have 1 over s plus 1. If you are very familiar with, this is the equation that we use to prove the poles. Okay, this is the equation that we use to prove the poles. And as also similarly to this thing, as I say earlier, if it's first order, yeah, you have minus 90 degrees. If it's second order, you have you add in another minus 90 degrees, so it will be 2 minus 90 degrees. Then for third order, you have another minus 90 degrees. So it is 1 times minus 90 degrees, 2 times minus 90 degrees, 3 times minus 90 degrees, and 4 times minus 90 degrees, right? So this is the trend for poles, okay? And similarly, this is the same because they are all poles also, right? So as you can see, for 1 times minus 90 degrees, the loop ends in towards minus 90 degrees, right? And as for this one, for the double leg, it ends at the third quadrant, okay? Because eventually it will comes back here in this direction, right? It will comes back here in this direction. So this is 2 times minus 90 degrees as well. And if it's quadruple, which is cube, you actually have minus 270 degrees, which is 3 times minus 90 degrees. And similarly, this is 4 times 90 degrees. They're coming in this direction. Okay. So in other words, in another analogy, okay, for the first order, it is in the fourth quarter plane. So let's say this is third, fourth. If you remember the plane system, okay, if it's 4, so this is 90 degrees right? If it's 180 degrees, it is into the third quadrant. If it's 270 degrees, it is into the second quadrant, and it goes back to the first quadrant. So this is the trend I want to convey. If you want to see the derivation, because it's very very tedious, I recommend you watch this one and polar plot for 3 simple poles. Okay, this is the same thing, you just expand it. Okay, so 1 plus st1, 1 plus ts times 1 plus s lah, in the sense that t1 and t2 are some constants only, that's all. So this is just simpler. So the video explains this trend in terms of this. Yeah, so you can see it, you can watch it, and then eventually you know that it is moving in this direction. So I just want to convey this is a very important concept. Okay, this is a trend you need to understand. So for a pole, for any transfer function, these are all transfer function, right? For any transfer function with no zeros, okay, with no zeros, this is 1, right? There's no zeros up here. Definitely you will see this type of trend if it's first order. If it's second order, it goes in this direction. If it's third order, it goes round back here. If it's fourth order, you go one big round back here. Okay? So I hope you understand this very key concept. And then now, okay, since you know this trend and you know this trend, what if we multiply them together? What trend do we have? Okay, this is the key thing I want to make sure you know, okay? So let's say if it's the integrator, okay, this integrator multiplied by this one, what do you get? Okay, if the first order integrator multiplied by the first simple leg, so simple integrator times simple leg, okay, so in other words is 1 s plus 1, what do you have? Okay, so nyquist plot shows that you are moving in this direction. Okay, so this as you can see, this axis is 0. Okay, because it's plotting in terms of, maybe I should show you, yeah, so this is the, okay, sorry, this is the trend, okay, this is so this line, this line is actually this portion over here. So in other words, maybe I should hold on a while. So in this case, this is the nyquist diagram, okay. and the line, this line is actually from 0 to infinity, minus infinity, where, I mean, this is omega equals to 0 to minus infinity. And this one is when omega is equals to 0 to infinity. Okay, so from 0 to infinity, and from And then from omega is equals to sorry, hold on. So you have to take a look, okay, from the positive side, okay, as your, so you are from 0 to infinity, right? So as you can see, it's increasing 0, and then it start to increase, and then increase and increase and increase and increase, right, to 0.8, and then furthermore, if you increase still, you'll go to 1.7 plus, right? And then for the negative side, you're actually decreasing, right? You're actually from minus 0.26, minus 0.3, minus, so you're from, you see, you're actually decreasing all the way. So if you were to take a look in this axis, you're actually minus 0.0, which is like 0, 0 lah, okay, 0 to minus infinity. So if it's 0 to infinity is this line, minus 0 to infinity, minus, from, sorry, from 0 to infinity is this line, from 0 to negative infinity is this line. Okay, so it's coming in this direction. However, this is coming here and then it goes in like that. So it's a little trend. And then you may wonder what are all these things. Okay, these are all the trends in terms of the full. Let's say this is, okay, where is it? As you can see, this one is actually what we are plotting in the nyquist plot now. Okay, it is s times s plus 1. Okay, as you can see, this is the trend, right? And then this is the negative, this is the positive. So if you were to, so typically if you draw in all your tests, okay, typically you can just straight away draw the positive side will do. And then you know that the negative is simply the reflection of the positive, that's all. Okay, so I repeat again, the negative is simply the reflection of the positive only. Okay, this is the trend. And therefore, as you can see in the picture over here, is actually negative and positive. That's why we have this trend, same as this. So this line, okay, it's positive, while this loop is negative. Okay, so if you don't get what I mean, okay, so this piece over here is what is this one? This is when omega is equals to 0, and then omega is equals to 0, and this is when omega is equals to infinity, and this is when hold on, yeah, I was wondering. Okay, so I just draw it out in order to show you in a more easy way. So as you can see, this is actually 0, from 0 to minus infinity, okay? 0, and then it slowly increase to negative infinity. Okay, it slowly increases to negative infinity. And as you can see, over here you have from 0, it slowly increase to infinity. Right? 1 point, now 2, and then as you go further, you are going towards higher values. Okay, you see? So this is the trend. Same as this, okay, so it's just simply reflection. This is the positive, this is the negative, that's all. Okay, so yeah, so I only prove to you only as s times s plus 1. What if s times s plus 1 square? Okay, what will we have to see? What can we see? Okay, so as you can see, if I were to, so this is a comparison between the, okay, what I did was actually this a is actually 1 over s, okay, the simple integrator, okay, it's simply this one. And then the k, okay, this k is actually s plus 1, okay, it's actually s plus 1, which is this one, okay, 1 over s plus 1. And then kkk, which is this one, is simply the 1 over s plus 1 square. So I did out the nyquist plot in terms of these two, okay. So in this case, s and s plus 1 square, okay. don't look at this one. Okay, I just writing so that you can easily refer. Is this one and this one. Okay. So if I were to compare the nyquist plot, the blue color one is actually this one, and the orange color one is actually this one. As you can see, if I were to, as the order increases, you actually you have a so-called a more asymptote towards another value. Typically, you will say that this is actually unstable already. Okay. Later in the next video, we'll talk about the nyquist stability thing, and then we'll know that -1 is actually the limits. Okay, so as you can see, this case this is stable, but however, if you go to a third order like this, in this case it's very unstable. As you can see, the frequency if you compare, okay, it's 0.2, okay, 0.285 is over here. As you can see, at the same frequency, their their magnitude is kind of different. Okay, the overall systems are kind of different. Typically, it's in the imaginary axis is the same. Okay, as you can see, they are the same height in the imaginary one, but their real axis magnitude is pretty much very big. So this is the difference between them. So you may expect, what if I were to multiply in 1 over s into here? Okay, what do I have? Okay, we take a while, so hold on. This is the trend, okay? So this is when, okay, so maybe I should hold on a while. Okay, so this blue line, okay, this one is actually S, and then this orange line is actually S plus 1 square, and then this is cube. As you can see, it is only moving in this direction, okay, and then the fourth order you see is asymptote to -4, the third order is asymptote to -3, second order is asymptote to -2. There is a certain trend, I can't explain, but this is the thing that is being shown over here. But as you can see, if you multiply in the integrator, okay, the simple integrator, you are moving all the root locus in this coming from here. Okay, if you remember, the simple integrator comes from where? Comes from the negative infinity up to here, right? It's coming in this direction. And then if you were to see all these things, they're actually coming from here. They're all coming from this point all the way here. They're all coming in this direction, right? But if you simply multiply the integrator into all of them, you're actually flipping the whole system to a negative 90 degrees. So the whole system would come over here now. As you can see, all of them are moving in that direction now. Okay, all of them are moving in this direction. As you can see, it's coming all over here. So you're actually flipping the whole root locus of graphs in a 90 degrees. So the integrator itself is somewhat flipping your root locus, your poles, such in as you can see, if you were to multiply integrator times integrator, right, you're actually flipping each other. You times let's say one over s, and then you multiply 1 over s. At first, 1 over s is minus 90 degrees, right? And then after that, you multiply another 1 over s. You're flipping the 90 degrees to another 90 degrees again. So you're flipping and flipping and flipping. So the more integrator you have, you flip the most lah. Okay? And because there is 4 columns only, the highest you can go is actually 4 integrator. Until that, what you do is actually a bit wasteful lah. But as you can see, this is a pretty much important trend, as you can see. So what about if I multiply 1 over s squared? Okay, so my root locus, every root locus will actually flips from here, right? It already comes from here now. But in this case, not, okay, because as you know, they're actually moving in a more faster way, so you may have some trends like that. Okay, so maybe you give me a while to plot it again. As you can see, if I were to flip it, right, all of them are actually flipping, coming from this direction. You see, they're all coming from this direction. Okay. Nonetheless, I may be wrong. Just now I said that you may actually like that. Okay. So no lah, actually it's like that lah. Okay, they all comes in this direction now. So yeah, actually, as you can see, you're flipping the locus. Okay, in other words, let's say you multiply 1 over s in this case. I rotate. Sorry. Okay, I rotate in this direction. Okay, and then if you want me to flip again, okay, in this case, 1 over, if you multiply the double integrator, okay, you are flipping it over here, which is what we have shown in this diagram over here. Okay, although it didn't cross over to the side. Okay, as you can see, they all, where am I? They all nice settle down on this section over here. They didn't cross over this section. Okay, they didn't cross. So the only thing you need to take note that, because I'm just trying to convey you that the analogy. So if let's say I multiply the third order integrator, okay, you will have some trends like that. Okay, so what if I did do that? Okay, so as you can see, so I multiply everything by a third order integrator now. As you can see, they all comes in this direction now. So you may want, because it's now it's positive lah. Okay, because just now it's negative frequencies, and now I just talk about positive frequencies coming in. As you can see, all of them comes as predicted. They all comes in this direction. Now if I were to multiply in the quadruple, okay, that means 1 divided by s to the power of 4. Okay, you have, what do you have? Okay, you have a much amplitude. Okay, more amplitude than, but you're actually so-called increasing the amount of instability in there. As you can see, this is the value, the real axis 1 is over here, right? You're only over here, but let's say if you were to compare back to the previous one, let's say I open up the very first one. Okay, maybe no, sorry, hold on. So if to compare, this one is actually the comparison between all the 4. Okay, all these 4, only 1, 2, 3, 4. Let away this integrators lah. Okay, so this graph itself only compares the initial condition, the initial one without the integrators, and then if with the integrators, which is with the quadruple integrator 1 over s, which is this one. Okay, with the quadruple integrator, you're flipping 360 degrees now, right? But the difference is kind of big. As you can see, you see I start at 1, and now I start from somewhere else already. You're actually amplifying the whole system quite a lot. Nonetheless, you're making things more unstable. Okay, so if you compare this point over here, okay, no need to this point lah. I cannot click anything lah. There's some trouble things over here. So, but nonetheless, you can see that the trend is moving in the direction. So hope I can let you understand. So this is a summary that I put out. Okay, if you have no integrator, okay, let's say this blue line, it's one, and then this line, okay. So this one is actually, so whatever here over here is actually the omega equals to 0 to infinity. Then whatever over here is omega equals to 0 to minus infinity. Okay, so that's to show you. And then this one is actually 1 plus s plus 1 square and then this one is 1 plus s plus 1 cube, and then the last one is 1 over s plus 4. So if it's no integrator, it is simply the root locus, as the very first configuration that I showed you earlier, all this stuff over here, right? It all comes there, right? So in a more clearer view for these things, just to show that they actually crosses the portion that I'm telling you. So if it's minus 90 degrees is only in the fourth quarter, if it's 180 minus 180 degrees is in the second, is in the third quarter, and if it's minus 270 degrees is in the second quarter, and if it's 360 minus 360 degrees is in the first quarter, as you can see. So this actually reflects. Okay, so this is the minus 90 degrees, this is the minus 180 degrees, this one is the minus 270 degrees, and this is the minus 360 degrees. So it eats into the plane itself. Okay, so you need to know that. And then let's come back here again. So you have clearly understand this one. And then if I were to multiply integrators, okay, same thing. These are all the 1 plus s plus 1, 4, and then so on and so forth. I believe you will understand already. And then these are the trends. As you can see, you flip the whole system in a, in a 90 degrees. And then 1 over s squared, as you can see, you are flipping in. And then 1 over s cubed, you are also flipping in. So in other words, I took away the negative frequency. As you can see, this is no integrator, right? And then if you multiply 1 over s, you are flipping this whole thing in the 90 degrees. And then if I were to put in 1 over s squared, I flip again 90 degrees over here. And then this is negative 270 degrees already. And then if I were to have 1 over s cubed, okay, this is 1 over s squared. If I 1 over s cubed, I flip another 90 degrees. And then minus 360 degrees. And then if it's 1 over s4, I flip to negative 360 degrees. I come back here again. Okay, I turn one round, then I come back here. So I hope I give you a very good understanding of all these things. So next video I will go into stability theorem. As I say earlier, just now I say that we cannot cross the boundary, 1 and minus 1. Why? The reason why. Okay, so in the next video I'll talk about it. As you can see, this is unstable, and definitely this is unstable. This is also, at this point it's still stable, and then it will be unstable over here, and then definitely these are all unstable at this line. Okay, so I'll just talk about it in the next video. So good luck. Bye bye.